One way that insurance companies can deal with the problem that they can't identify who the safe drivers and who the unsafe drivers are is to get information on who's safe and who's unsafe. We can imagine, for instance, a screening industry emerging, an industry that gathers information on drivers and sells that information to insurance companies. Suppose again, as in graph 22.1, that safe and unsafe drivers have the same demand curves for insurance. And suppose again that we can interpret these demand curves as marginal willingness to pay curves. If insurance companies have no information on who's safe and who's unsafe, a competitive insurance industry will charge a single price P star to all consumers, with both safe and unsafe drivers purchasing X star in insurance. But if insurance companies can tell who the unsafe drivers, the type 1 drivers with high marginal cost, are, they'll price insurance policies for unsafe drivers separately at P1, causing unsafe drivers to purchase X1 in insurance. Safe drivers, whose marginal cost is lower, will then be charged a separate price equal to their marginal cost, causing them to consume X2 in insurance. We're assuming here again, as in graph 22.1, that there's an equal number of safe and unsafe drivers, which causes P star, the price that emerges when insurance companies cannot tell the difference between safe and unsafe drivers, to lie halfway between the two marginal costs. In graph 22.1, we then determined that the deadweight loss from not being able to tell who is safe and who's unsafe, and having to charge P star in the market, is equal to areas F plus G. If firms in the screening industry can determine who's safe and who's unsafe at zero marginal cost, the equilibrium price that will be charged for information sold to insurance companies will be zero per customer. In that case, insurance companies can costlessly buy the information they need to establish separate markets for unsafe and safe drivers, and thus recover the deadweight loss F plus G. But if the firms in the screening industry incur a positive marginal cost every time they screen a potential insurance customer, they will have to charge that marginal cost to insurance firms as insurance firms gather information. With this information, insurance companies can then charge different prices to safe and unsafe drivers, but they can't charge a price higher than P1 to unsafe drivers, because if they try to, another insurance company could form and simply charge P1 to everyone. Unsafe drivers would then buy insurance from that insurance company. The cost of paying for information from the screening industry must therefore be passed on to type 2 safe consumers. Suppose then that the cost of acquiring information is such that the equilibrium price for type 2 insurance policies that emerges is P2. This will be the price at which the insurance industry makes zero profits after purchasing information about which drivers are safe and which are unsafe. Safe drivers are charged P2, higher than the marginal cost that those consumers impose on the insurance industry, because the insurance industry has to pass along the cost of acquiring information. Unsafe drivers, type 1 drivers, will be charged P1. In the separating equilibrium that emerges, where type 1 consumers are charged P1 and type 2 consumers are charged P2, consumer surplus for type 1 consumers will therefore fall from A plus B plus C, when price was P star, to just area A when price rises to P1. Consumer surplus for type 2 consumers will increase from the initial A plus B plus C to A plus B plus C plus H plus I. The cost the insurance company paid for acquiring information is area J plus K. The insurance industry pays this cost, but the screening industry makes zero profit. So this is a loss in surplus. We therefore get a gain in surplus of area H plus I and a loss in surplus of areas B plus C plus J plus K. In the graph as drawn here, it's clear that the H plus I gain in surplus is smaller than the B plus C plus J plus K loss in surplus, and thus the purchase of information has actually led to a decrease in surplus. The example illustrates that because information is costly, it's not at all clear that gathering information in order to resolve the adverse selection problem and establish separate prices for the two insurance types will decrease deadweight loss. Here, in fact, the information was sufficiently costly for deadweight loss to increase as a result of the separate prices being established once the information was bought. As information becomes less costly, P2 would fall and ultimately converge to MC2. As information becomes less costly, the area J plus K therefore shrinks, and the area H plus I increases in size. And at some point, information is sufficiently cheap, such that the gain in surplus of H plus I is larger than the loss of surplus of B plus C plus J plus K. Gathering information in order to resolve the adverse selection problem and establish different prices for different types may therefore decrease the deadweight loss if information is sufficiently cheap. But if information is sufficiently expensive to gather, the deadweight loss from resolving the adverse selection problem will actually increase because of the cost of gathering information.